So, hi everyone. Welcome to another episode of Funding Stories, episode number 12. I'm Yoav Joe Sadan, and with me here I have Adam Davis. He's the founder of Amalgamated Vision. What we do at Funding Stories is we bring awesome companies that, yes, have worked with us, and we talk about their journey, their founders, what have they done as a whole, and their part and their stories in kind of in success, also what they did with non-dilutive and R&D grants and contracts. So with me here, I have Adam Davis. Adam Davis is an MD who was trained and certified by University of Pennsylvania and has been a practicing physician at the Bellevue, New York hospital since 2008. And we're going to talk about their story that led to Amalgamated Vision. Amalgamated Vision is essentially what Adam has on his face right now. It is a near eye, non invasive device that allows very high quality direct retina display that is non invasive, but does allow you to still not have a disruption to what the person is looking at. So I'm probably botching the description of Amalgamated. That's not the LinkedIn description of what they do. So he's gonna get a chance to correct me and make me look like a fool. But we'll start with that. Hi, Adam. Good to see you, I have to say.
And it's great to see you. Thanks for the invitation to your show. I'm actually looking forward to this conversation. I think it'll be fun.
So you started as a doctor, pride of every mother, and then you decided that that wasn't good enough, and you decided to start a company. So tell me a little bit about that. How did you become a doctor, and what made you start a company?
Well, I started as a physician. I had an interest in how the brain works. I started out going into neurosurgery, and I was in neurosurgical training for several years before I decided to switch over into radiology. And I did that because radiology offered a minimally invasive way of getting into the brain through catheters through the bloodstream to get up into the head and do procedures in the head without opening up the head, without having to do a craniotomy. And I trained in that, and I went into practice as a diagnostic and an interventional neuroradiologist, reading images about the brain and the head and the neck and the spinal cord, and also doing procedures, treating diseases of the brain. And during my training, I became enamored with 3D stereoscopic imaging. And by that, what I mean is looking at X-rays, angiography, or sometimes even reconstructed MRIs or CTs at two different points of view, 6 degrees of separation of the same content. And by crossing your eyes or using prism glasses, it puts depth. It brings out the spatial relationships of the images that you're looking at. And it's like the old, viewmaster of the viewmaster of the Taj Mahal. You'd put it up to your eyes and
Oh,
you'd see
wow.
the Taj Mahal in 3D, except we were doing it with angiograms or a blood map of vessels of the brain. And I realized that visual augmentation was a very powerful technique. It wasn't a new discovery by any means. Actually, doctors had been using stereoscopic imaging for decades. Back in the 50s and 60s, they would take X-rays from two different perspectives and then put them on a view box and use a prism glasses to see depth, of the chest X-ray or some other X-ray. And when CT and MRI occurred, it became less popular because people didn't need 3D stereoscopic. They had slices through the body that enabled them to look into the body. But it lost that really powerful stereoscopic technique. And I like to say it's more than a parlor trick when you use stereoscopic imaging. It actually invokes parts of your brain that allow you to see the information differently, gives you a different insight into complex spatial relationships. And people have rediscovered that recently. I was, gratified when virtual reality first came out, and people were commenting on the emotional experience of presence. They put on a
Okay.
VR headset and they felt as if they were there, and you'd say, oh, it just looked better. And they would say, no, I really had a different way of experiencing what I was seeing.
Hmm.
And people like to attribute that to virtual reality, but I think it really has to do with the 3D stereoscopic view that you're looking at. It invokes parts of your brain that has to do with language. And I think that's a different way of looking at things. So when I went into practice, I became more and more interested in visual augmentation. How do you look at things? And back in the 90s, was working on um, Sun workstations, dating myself. That's a old computer stations, the Sun workstations back in the 90s, because those were the only things powerful enough to take CT data or MRI data and turn it into a 3D representation that you could move around. It's much more commonplace to now, today, because people have CPUs that can handle that kind of material, but back then it was much more difficult. So I was working on those workstations back in the 90s and the 2000s, and I realized that taking medical data and reconstructing it and then manipulating it in 3D was a more powerful way to present complicated data. People were looking at CTs and starting to look at, as CTs got better, they were generating hundreds, thousands of slices. And
Hmm.
people would be rolling right through them very quickly. And it was okay if you were a radiologist with, 30 years of experience. But if you were a new radiologist, you were not getting all that information. You were missing some of that complex relationship. And I knew that you could convey those complicated relationships, the distances between things, small structures that you'd normally ignore because you had so much information going on. You would ignore the subtleties of it. You saw that with rendering, with 3D renderings. So I became more and more involved with that. But the interesting thing was that even though doctors that we would work with would see these 3D renderings, and they really enjoyed it. Many of the doctors who were most interested in it, which were the surgeons and the interventionalists, men and women who really depended on that data before they went in and did a procedure. People who really wanted to make sure they knew what was going on before they started to go to work. Um,
Hmm.
they loved the information and they hated the format, because the one thing that
Hated the
surgeons,
format.
in the sense that they were not going to wear glasses. They wanted nothing on their face. There are very few people on this planet who are less tolerant than surgeons when it comes to being annoyed. Comes to being annoyed. These guys are working. They don't want to be bothered. They don't want something on their face. They don't want to be distracted. And that's, well, I think that's a good thing. Um, but that heads up information that we were giving them was
Hmm.
really powerful. Because as a reference, as a guide, as a continuous check where they were, what they were doing, what the initial problem was. Um, so about 20 years ago, we were thinking, okay, how do we give visual augmentation to healthcare professionals,
Hmm.
uh, but make it as unobtrusive as possible? And we were familiar with the idea of having LED glasses, which would go back, they would alternate back and forth and show you 3D stereoscopic images. And we were just at that time, just starting to see displays that would be up in the corner of your eye. And it was just too bothersome to physicians, and it was just there was too much of a cognitive burden. It was too much distraction. There was too much
Cognitive burden.
cognitive burden. You to think about when you see the world around you, you need to compute what you're seeing. And
Mhm.
you have a natural capability of viewing the world and seeing what you're looking at, and then maybe looking down and looking at something else. But when you start to superimpose multiple things at the same time in someone's vision,
Mhm.
you have to deal with that cognitively from a thinking point of view. You have to unpack everything that you're seeing. So if you're trying to concentrate on information, digital content that's floating over the world in front of you, that can be confusing. And it
Mm.
could create more than cognitive burden. It creates, you get these physiologic disturbances in the fact that people have headaches and eye strain. It can create a nausea, and everyone knows with VR there's cyber sickness because your digital world doesn't match with your physical world. There's convergence accommodation problem where bringing the eyes in to see something, the distance of what you're looking at in the digital image doesn't match the distance of what your eyes are actually looking at in real life. So that disconnect creates all sorts of problems for the viewer. And we thought, well, how can we simplify all of this? How can we show people important information, not block their vision, give it to them simply?
Mhm.
And we settled on a different way of presenting data. And I fell upon the idea of using laser beam scanning or virtual retinal display as the light source. And I actually learned about it reading Wired magazine, where all good ideas come from. I didn't even know about it. I read that there was a company on the West Coast, a company called Microvision, that was producing these laser MEMS that came from the Washington University. And what they were doing was taking different laser beams, red, green, blue. At the time, it was only one color, but red, green, blue later, and you would combine them into one beam, and they'd bounce that beam off of a mirror, and that mirror would go back and forth very quickly, and it would
Mm.
paint by turning the lasers on and off and using different colors. It would paint a picture, and you could present that. And that was just like an old cathode ray tube, like an old TV set that had,
Yeah.
that had the beam going back and across through the phosphor. Um, and it was good for shining that, on a wall to paint a picture on a wall or something like that. But they had the idea that maybe you could take this beam, okay, and turn it around and project it directly into the eye. So you'd paint the picture on the back of the eye on the retina.
Mm.
And that was an interesting idea. And it was a successful idea in the fact that it could be done. And it was a very compelling demonstration of using lasers, to present material. The problem with it was that you could squeeze that diverging laser, okay, through the eye, but you couldn't get a large field of view. You could only see a very small amount of the picture. And also,
Mhm.
you had to line up your eye exactly with the mirror of that mirror that was going back and forth. If they weren't perfectly aligned within about a millimeter, because that's how big the beam was, a millimeter, you would miss the picture. It would fall out of view. And that stopped direct retinal projection, in other words, projecting the laser beam directly on the eye, or virtual retinal display, meaning it's a virtual display on the
Hmm.
retina. There is no picture until it appears on your retina. Well, it stopped that in its tracks because people didn't think that you could use a laser beam display, laser beam scanning, to project into the eye because of those obstacles. No, you couldn't get a large field of view. You couldn't make the exit pupil, the sweet spot you could see it from. You couldn't make that large enough.
Hmm.
Um, and that's what we tackled. And that was back in 2010, 2014, 2016, 2017. We started working with engineers who were familiar with this. It took a while, and we found an engineer, Dave Kessler, former Kodak engineer,
Hmm.
who was expert in laser light, and he was able to solve this problem for us. And that is the heart of our company, is this intellectual property that is
Hmm.
the optics that enables us to shine the light, squeeze it through the pupil, but give a large field of view so we get a large image, and create a large exit pupil so that when the eye moves around, you still see the picture. And by overcoming those physical obstacles, basically through smart engineering, and our engineers are just fantastic. Through smart engineering, we were able to turn this concept into a practical device.
Mm.
So I say that like it actually happened, but it didn't. That all happened on paper. Those were patents. That was, engineering. That was us, trying to solve the problem.
Hmm.
Um, in reality, what happened was that we wanted to build a device. We were presenting a device that was dramatically different than the way the market was moving. And because of that, we had difficulty getting traction because we
The market
said,
was moving somewhere different.
yes, um, the market was moving in the direction of see-through displays. Everybody saw Tom Cruise in Minority Report, and everybody thought that the way to show data would be by putting digital content on glass that you could see through, and it would be superimposed on the world around you. And everyone thought that was uber cool. And
Are you
that
blaming Tom Cruise for where the industry has went?
well, no, I want to make that perfectly clear right now. If he sees this, you're a great actor. I love you. Okay.
Apologies to Tom Cruise.
Um, no, actually, I actually blame it on the large technology corporations around the world that jumped on this idea, and all of the venture capital money that followed them, because
Interesting.
it was difficult to say to people, our idea of visual augmentation is make the device as small as possible. Keep it out of the way of someone's normal vision so it doesn't obstruct their vision. And when they
Hmm.
want to use it, just have them look over to the side to see it. And we had a slightly different idea originally. Originally, we were going to put it below the eyes and look down,
Hmm.
and it was a bit larger. But we were going to look down and you'd see two different displays, and you'd get this very rich 3D stereoscopic image. We later
Hmm.
morphed, pivoted, and developed this, and we could talk about that in a little while. But when we would say to people, this is our idea of how visual augmentation could happen, they would look at us and say, well, why should I believe that you are going to be successful when companies like Microsoft with the HoloLens
Mm,
and Apple and Meta with see-through excuse me, with pass-through displays, and companies like Magic Leap, they were attracting billions of dollars or internally investing billions of dollars in a see-through technique or using
mhm.
video of the real world with digital content blended, that technique. So we got hammered by the marketplace because we were so distinctly different. Um, so that was the rude awakening. That was the rude reality of being a startup.
And you designed, and the concept was, how do doctors or people actually want to use it? And the rest of the industry was, how do we market it?
Yes. We were, and I think it's an age-old tale. We were solving a practical problem that people had, and we knew our audience. And actually, we knew, what people wanted, what people like. People do not like to be bothered. They don't want a cluttered view in front of them. But it took a while for people to come around back to us and say, oh, this is interesting. We had to wait for these massive technological products
Mhm.
to fail. And maybe not fail, I think that's the wrong word, to stumble is, I think, a better
Yeah.
word, before people started to take us seriously.
I remember you and I had a discussion before one of our pitch events, and we said, if we're just gonna present Amalgamated Vision as another 3D display, it's gonna be very undifferentiated. And then I remember at the actual pitch, you showed, I don't remember which type of plane, crashing into an aircraft carrier because at night during a storm, they couldn't get the damn display to move when they actually wanted to see the landing track.
So that was the 900-pound gorilla in the room. People were, just because technology is moving in a direction and companies want it to move into a direction and VC money is following it in that direction, doesn't mean it's the best solution necessarily. Um, it had become obvious to many people, the military in particular, that a see-through augmented device certainly had benefits. I'd like to say now, no device fits all. We have a great solution, but I want to say that certainly for other applications, there will be different ways of seeing things. But there were some problems with see-through augmented reality, and people were ignoring it. The what you're referring to are the heads-up displays that are in the F-35 fighters. These are $400,000 helmets that projected, displays on the concave surface in front of the pilot. And yes, they're great, but they also have a downside. They blind the pilots to some degree because of the amount of, brilliance of light that's going on in the helmet. It creates a lot of clutter of information for the pilot. When it's dark out and your helmet is bright and there's a tremendous amount of light around the eye, it's difficult to actually see the world around
Mm,
you. They have a monocular device in the Apache 64 helicopter. And you would fly and you would have the monocular device over one eye. You'd be looking through it and with the other eye looking at the world. And what they found is that Apache pilots would be closing one eye and the other eye to either look through the device or look at the world. Not what it was intended to do. You have these pilots flying, closing their eyes, alternating in an alternating fashion. And the most widely advertised problem with augmented reality, see-through, was the IVAS program for the Army. They use these Microsoft HoloLens devices. They put them on the head, and it was in front of the eyes. And the soldiers uniformly rejected them because well, first of all, they were heavy, so it created, headache and eye strain and neck problems. But also they found it created kind of visual confusion. It created nausea. So it really wasn't particularly helpful for that indication. So it's um, so it's important to realize that visual augmentation is
Hmm.
extraordinarily powerful, giving people uh, critical information on demand, when they need it, will certainly improve task efficiency. It will
Hmm.
it will improve task performance. And that's been shown over and over again that, if you give people information on demand, they do better. Uh, but the problem was you needed a form factor that people would find acceptable. And that's where we step in.
Mm. So you mentioned the market went after Tom Cruise and VCs in Hollywood and Glass, and then a bunch of products failed. Is there something you wish they would have told you before you started the company, or what stuff did you figure out along the way as a learning process?
Uh, a lot of things. Um, um, I, 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 I think I was naive about a startup. I came from medicine, and you know, um,
You were
uh,
naive?
I was naive in the fact that when I came into the startup world, I kind of thought that build a better mousetrap and they will come.
Hmm.
And it is not like that at all. You need a good product, certainly, and you need a product that differentiates you from the marketplace and a product that solves problems.
Hmm.
But you also need a really cogent plan, and you need good fundraising capabilities because we're a hardware company, and the startup costs are huge when you're building hardware. And that was, one of our difficulties was that we were building a product to go up against companies that were spending billions of dollars developing products. Um, I like to joke that if it's a this is not true, but I like to joke, if you have a software company, you take two people, put them in a room, give them a case of, Red Bull, and 6 months later you get your product. You get, lines of code, you get software, and you're ready. But with hardware, you have to obviously do all the designs, but then you have to actually build it. And building is cost intensive. You need a lot of money up front to build something.
A
And
lot of money.
a lot of money up front to build something. Especially if it's something that's very technical. We're using laser MEMS. We have sophisticated optics. Many of it is custom built. And we have jammed all of this into a very small space. We're building it out now, but we're at the limits of what human beings can build. Where this is being built using um, a, a digital surface profiler, so you can measure things in microns. They're building it with a stereo microscope so they can see their hands to build this. Um, and to go back to the original question, I wish I had known how important uh, raising money and how difficult it would be getting it. We thought that we would receive private funding because we would pitch this and people would say, "Ah, that's great. We see the future." Um, and what's interesting is everybody said to us, "That's great. We love this. Come back to us when it
But
works." uh, because what we also discovered was that venture capital money is very conservative. You know, venture
conservative.
Yes, it is. I know people like to think of venture capital as the captains of industry that take huge risks to move things forward. Um, but I find that most VC investment really goes to products that are proven, starting have early revenue, and now it's time to scale. And that's when VC
Interesting.
and that's when VC money starts pouring in. Or you have a track record of winning and you've already had two or three startups and you have those connections within the VC community, and they believe in you and they believe in your team. So even though they may not understand what you do, they believe that you'll make it rain. And that's the hard truth about raising money when you're a small startup, particularly if you're pre-revenue like we were, um, and particularly if you're different than the rest of the
Hmm.
industry. If you're truly a novel solution, I mean, the assumption is if you're a novel solution, you're disruptive. People love throwing that word around, and Silicon Valley and VC money, they're disruptive.
You're,
Not
you're
not
disrupt you're disrupting their line to the next coffee place.
right. You're not exactly. They want a more sure bet to get a return on their money. Um,
Mm.
and our first funding came through. It was initially friends and family, and then it was some angel money. Someone who um, CEO of a small software company liked what we did and gave us some money. And we were able to do some early designs. But our first real money did not come in until we won a contract with a West Coast data analytics company. And they what this company um, does is they take disparate types of data, radar, satellite imagery, LIDAR, seismographic maps, emergency medical maps, and emergency responder maps. And they take all these different types of information in different formats and through a novel software architecture and through novel techniques, they bring all this data together into a single comprehensive visual experience. So then and it all is co-registered together, and you can kind of peel back the layers to see what you want to see. So
Mm.
they were becoming very successful at putting this all together in code, and then they realized that they didn't actually have a way to visualize what they were putting together. They tried many of the augmented reality displays that were out there, and they discovered exactly what everyone had been understanding, which was the image quality was not good. It removed you
Mm.
from your environment. It was, distracting and all of those things. So they investigated the field. They bumped into our patents. They contacted one of our engineers just through, a contact through a university. One of our engineers Randy Sprague was contacted. And he said, I may have a solution for you. So this company um, paid us to design a system that would be useful to them, which was this very high quality, complex, but high quality look down display where you could look down, get a very high resolution image,
Hmm.
a field of view, the equivalent of a laptop at about 18 inches, and then you'd look back up and you'd see the world around you. Now, for someone like the military, that would be limiting because it blocks your vision a little bit down below. You
Yeah.
you can't see your feet, but you could certainly work in an office space
Yeah.
or something like that. You can't run through the jungle wearing this; you trip over logs. But it could give you a visual augmentation experience in a controlled setting.
Hmm.
Um, and they really moved us forward. They gave us significant funding, and we were able to go through the critical design phase up to the point where we were ready to build.
Mhm.
And because of geopolitical problems and financial problems, this company needed to suspend our funding. So
Oof.
it left us in a lurch. We moved all the way forward to the point where we were ready to start building a device. And then the financial rug got pulled out from under our feet.
Sounds like that wasn't a good day.
Uh, no, not for us, but it was for you because that is when we decided we need an alternative source of funding. We need somebody who's willing to take a risk on technology that is next generation. And up till that point, we had not considered government funding. We really, again, we were naive and we stayed in the VC angel world. We had funding from this company, so we didn't, we were doing well. But then we realized we needed funding, and um, at that point we decided to throw ourselves fully into trying to obtain government grants.
Yeah, I think we met. I think we started working when we met January or end of 2022, and started working January 2023.
Was
That
it?
makes sense.
Yes, that makes perfect sense. That's
And
thinking back, I remember that's when we were broke. So that's actually when we started working together.
it's not a good memory I want to be attached to. We were broke, and then Eagle Point asked for more money. So
Well, we're
tell
glad
us,
we found you. You turned things around, so we're glad we
yes,
found you.
me bugging you paid off.
Yes.
Um, so we started around January 2023. If it looks like we're being honest, there wasn't a lot of runway left for the company,
No,
and
no.
and we said, all right, let's do this. And you folks started hitting it big. If I can, you folks won um, Air Force, you won NASA, and then you won again Air Force and that. So you have 4 wins with the government in a pretty short period of time,
Correct.
both phase ones and phase two. I don't remember the exact numbers.
In 2023, we applied for phase one grants from, as you said, from NASA and from the Air Force. And within 6 months, we won two phase one grants. I think the total that we were awarded was 225,000 between those two grants.
Okay.
And that one, it got us up on our feet. Um, and we were able to start moving forward again, start doing design. Did not enough money to build, but enough money to do, design again and to serve the needs of our clients, and that it was, the Air Force and NASA. And it also turned around our culture, turned around our mindset. It kind of lifted our spirits and made us more forward thinking. When we went into it, we uh, had no idea how to obtain government funding. I think it's a daunting task. Prior to this, we didn't consider it prior to 2023 because it just seemed like it was such a complicated, protracted process. And honestly, the verbiage is so confusing and the terminology is just so confusing that it is a difficult system to understand. It's a difficult process to navigate. And That's actually where EPF, took us by the hand and guided us forward. Um, I I think it was essential actually to win to starting that process. It was essential. I do not think we would have been able to do it without a guiding hand. And I know that you can certainly do the SBIR process on your own. And what's interesting is that at until our phase ones ended was the first time that I actually understood how the phase ones worked. All the
Mm,
way beforehand and during the process, it was very opaque. I didn't quite, it wasn't until we went through it that we were able to look back and say, ah, now I understand why this and this and this and this and this. So to have, to have a an SBIR guide, someone to hold your hand, is very important. Not only is it important because it keeps you focused in the right direction, but it's also more time efficient. You could easily burn dozens of hours on reading the instructions on each volume. And there's a big difference between reading it and having someone explain it to you or tell you what it is and then reading it and understanding it versus being alone and tackling it on your own. Big difference between those. It's a much more efficient process when someone guides you through it. The second thing was that, like probably like every other startup, we know our technology cold, and I know how to pitch it. I certainly know how to pitch it. But that doesn't mean I know what makes an effective argument for the Air Force, for AFWorks, or
mhm,
or for NASA. They have a way of judging your application, judging your proposals. That's idiosyncratic. They have their way of doing things.
mhm.
It's helpful for someone uh, to give you advice along the way about what the best way of applying is. The other interesting thing is I think that um, our experience with EPF wasn't how I thought it was going to be. I think it's different for every client. But for us, I'm a bit obsessive and like to be in control. So I wanted to write the technical volumes. I didn't want anybody else to write the technical volume but me. So I spent a lot of time doing that. I know that, you can certainly receive help doing that. And I wanted to do that. So I think if you're in a startup, you'd say, well, Adam, if you wrote the technical volume and wrote that big piece of it, why would you need somebody to do it? And the reason is because after I wrote it and I gave it to the people that we worked with at EPF, they shaped it. They moved it around. They emphasized certain things. They told us where to edit, what to expand upon. That was very helpful. It was extremely helpful. So I
For
think
the record, I'm not paying Adam to say these things.
no, it's this is no, this is just the way it is. I anybody watching this, has to know this because if you go to the SBIR website and you log in and you start looking at the application process, it is overwhelming. Now, I can say
Yeah.
that now that we've won a phase one and a phase two, and a phase two is even more daunting because there are such things as you need oh, what's that called when you get sign off from someone else, a memorandum?
Customer memorandum,
Thank you.
MOU.
Right, an MOU, customer memorandum. Obtaining a customer memorandum, going to someone in the government and having them sign a piece of paper that says that they're interested in your technology. It sounds like it should be the easiest thing in the world. It is not. We were banging our head against the wall. So there's certainly, different strategies to go about how to do this. EPF was very helpful in guiding us, how to do this. I think they probably saved us a lot of time and effort by um, just giving us guidance on what's the best way to proceed to obtain, to obtain these customer memorandums.
It sounds like the grants. Yes, I'd love to toot my own horn for the next 15 minutes, but it sounds like the grants and the project made a pivotal role for the company.
It absolutely changed everything. We won, the phase ones. We won, uh, I believe, 225. And then with the phase twos, we've secured $2.1 million in contracts with NASA, with their Exploratory Medical Capabilities Group, and with the Air Force for the maintainers, the people who take care of the aircraft, in this
Hmm.
case, the C-17s at Joint Base Charleston.
Hmm.
And what's nice was that, a couple of things. The government is willing to take chances on technology, and that's nice.
Disruptive technology.
Disruptive technologies, things that are a little crazy. They're like, okay. Um, and their end users get it because their end users have real problems that need to be taken care of. And for the Air Force, and we just visited Joint Base Charleston and met with their personnel, with their Spark Innovation team, and with their maintainers. The issue is that these men and women are repairing planes, and everything they do is with uses technical orders, which are,
Hmm.
to take them through the process. And all of this is on these large, bulky, ruggedized laptops. It's like walking around with a briefcase. And all of these maintainers have this laptop and they're using it. And it's informative. And in that regard, they like it, but it's heavy. It's hard
Hmm.
to use it. If you're working inside an engine, where do you put your laptop? Because
Yeah.
they are instructed to refer every step. They refer to their laptop, make sure they're at the right part. And it's a quality assurance check, but it's difficult to use that. Um, if they're doing avionics and they're deep in a hole when they're wiring things, it means they have to every time get out, look, put down their tools, scroll. So the idea that we can present to them the schematics they need, the checklists they need, and just give it to them on demand, and then they can have their tools in their hands and keep working. That very enthusiastic about that. And that was very
Reduces maintenance time, allows onboarding. You can have somebody that's not as senior doing the job, and
all of that. We're going to hire you as a spokesperson, all of those things. Absolutely. And it was obvious to them. So the nice thing is that, the military has issues they want solved. And the SBIR program is meant to find technologies that will do that and fund them. And, we're answering that call. And if we can help them out, that would be great. Serves our company well, and hopefully it'll serve the Air Force. For NASA, our end users are the Exploratory Medical Capabilities Group, and these are NASA personnel and physicians who are cognizant of the fact that as NASA goes on more extended missions, as NASA goes to the moon, and eventually as NASA goes to Mars, they want to be sure that if there is a medical emergency, they will
mhm.
be able to deal with it. So,
Wow.
and it's scary, but it's risk mitigation. They know that they have really smart people who are cool under pressure and who can follow instructions, and they want to be able to talk them through an emergency medical procedure.
Hmm.
If let's say you have trauma to the chest and you have cardiac tamponade and you need to remove blood from around the heart, or put a needle into the chest to reinflate a lung, or even a dental procedure. Someone breaks their tooth and you need to just do a nerve block. These are procedures with needles, and you can talk someone through it. Believe me, it happens in medicine all
Yeah.
the time. You take an intern, who doesn't know how to do these, and you talk them through it. So these are mission specialists and astronauts, and you're talking them through the procedure. So, but what they wanted was a device that they could wear that was very low profile, did not obstruct their vision, and would
Hmm.
enable them to use tools, but they'd be able to see step-by-step instructions.
Mm.
So that's what brought them. That's what brought them to us. That's why they were interested in our device. This is very light. Our entire device, including the electronics on the back of the head, the electronics and the batteries. This is the entire unit, and this is going to communicate wirelessly with something that provides content.
Hmm.
This is 90 grams. This is 3 ounces. That's the entire
Wow.
that's the entire headset. So, when you're in space and you're moving around, if you have something big and clunky on your head, you have to move that with you. If you have a visor in front of you and you're sweating in space, it doesn't run down your face, it floats out onto the screen. So to have something non-obstructive is very beneficial to them.
So with the 5 minutes that we have left, tell us where you are now, where you want to direct the company a year and a half to the future.
Okay. Well, I will tell you where we want to be in a year and a year and a half, and I could tell you that in a week that may change because unpredictability is the name of the game. I read somewhere that someone said, running a startup, I had some of the happiest days of my life and the worst days of my life, and sometimes they were the same day. And that is very true. So as where we are right now, the next 6 to 9 months are planned out. Right now, we are building out a working prototype right now. This is a 3D print. We do this for ergonomics. We are
Hmm.
trying to figure out what's the best way to sit on the head, what's the best way to run the cabling. So this is a 3D print, non-functional, but just for the structure and the ergonomics. This summer we will be delivering working standalone headsets to the Air Force and to NASA to try. Not commercial prototypes because they're
Hmm.
going to, but proof of concepts. We'll put them on them and we'll say, do you like this? And
Hmm.
that's what we're doing between now and Q3. We'll be building this out, delivering it to our customers, getting feedback from them, and then thinking about how we can make it better moving forward.
Hmm.
In the meanwhile, we plan on our funding right now covers our basic costs. It is, we run very lean to, even though 2.1 million sounds like a lot of money when you're building a headset, we blow through that money quickly. We have a high burn rate because we're buying materials and they're costly.
Yeah.
So we plan on applying for further funding, extension funding for the Air Force, things
Hmm.
like TAC-FI and STRAT-FI, and for NASA, their phase 2 extensions, in order to bridge us once the prototype is built to that next phase. Because my understanding is that many startups fail after they have a successful prototype because they run out of steam and they can't bridge that gap to the commercial product. So
Mm.
we're going to now work on early, start thinking about how do we get further funding to bridge that gap. And then if everything is successful, we're speaking with other companies, we're going to partner. We're a small company, very difficult with 11 people, associated with your company to pitch to, military command about large programs. So we're speaking with other companies about putting a solution together for an eventual phase 3. That's our hope, is to have phase 3. And once this works, or even before then, because people are now seeing what we do much better, much more
Mhm.
clearly, is along the way, hopefully attract some venture capital along the way, some angel funding along the way to keep us going. And
Sounds like from a significantly better position now,
yes, we
using the
are.
government project.
Exactly. It is, it has given us a foundation. The SBIR money has given us a foundation to jump off from.
Amazing. So we're just about out of time. So if you have final remarks, now would be it. But we'll be uploading the episode and we'll be adding Adam's LinkedIn and Amalgamated Vision. So if people are interested, we'll be able to later see it on YouTube and find a way to contact you.
Well, final thoughts. Well, first of all, thank you. Thanks for the opportunity to be on your show. I enjoyed this conversation.
One
I
one final thing. Sorry for cutting you off. That's the fault for having ADHD and a newborn daughter, but also the phase threes, and for people in the audience and people watching this later, there are matching funds. So there are actual programs. You mentioned TACFI, also NASA has the CCRPP, or in short, CRAP, the Civilian Commercialization Readiness Preparation Program. I did not make these acronyms; they did, and they should fire the marketing person who did.
Right,
But
but that's why you need EPF to translate that.
yes, but there are matching programs that say if you can find matching dollars, and if you can find somebody from the commercial sector, potential client or investor, then some of these programs say, all right, we'll match you dollar for dollar, and you don't have to dilute as much. I know you folks got matching funds from like the state of Tennessee based on your SBIRs. So
Yes, that is
there's a
correct.
lot of stuff. There's a lot of stuff there to push you forward.
Right. And that's true. Thank you for bringing that up. The SBIR opened other opportunities for us. The state of Tennessee has in order to promote entrepreneurs and startups within the state in the technology realm, they offer matching funds for phase one up to 100,000 US dollars, for phase two up to 300,000. And that certainly is instrumental in helping you broaden out your operations. Because remember, SBIR is very focused on doing the technology, but you also
Yeah,
have to have things like accountants and marketing and people who run your operations. And that additional funding is very helpful. So I want to thank the
yeah,
state of Tennessee for that. The other thing is that when you win an SBIR, it gives you notoriety. It raises eyebrows. People tend to take notice. And because of these SBIR additional funding that's available, if a private investor invests in your company, the government will match that money. So the private investor is getting double bang for their buck with a non-dilutive source. So it's a
yeah,
very, when you were in the SBIR program, it's very attractive to the private capital investor.
yeah. It's just hard getting. It sounds like it's hard getting started, but once you're there,
Yes,
it's it the what do you say? The dominoes start falling.
very, very true. The first dollar is the hardest dollar, by without question. And as you go on, you just attract more attention.
Yeah. So Adam, thanks a lot. This was a lot of fun. For the people in the audience, we'll leave all the details to contact Adam and the people watching us in the future. It's going to be interesting to see how and kind of what's the path forward. So thank you.
Thank you, Yav. Thanks very much. You take care.
And